Yes, good evening, everybody. Good evening. Good evening, Sharmita, Janni, Dharshini is also here, Potri and Aarti. All of you. A very happy evening. So tell me, how are you all? We have 10 students right now. That's good. How are you doing, all of you? Yeah, that's great. I'm also good, dear. Good evening, Rahul. So let me see. We have Aarti, CP, Dharshini, Janni, Jai Govind. I mean, all of the students are old student only. Nobody is new for us. That's good. Let's move forward now. Here we go. So in the last class, what we were doing, remind me some, I mean, it's been a while we haven't had a class. So just give me an idea what we did in the last class. I was discussing other types of function. In the types of functions, what did I discuss and what I did not? Types of function, how many types I discussed? How many types did I discuss? Like one time is one function and the other one is many function. So one I have discussed, many one also I discussed. Okay, one discussed, many one discussed. That are two only. So I have to discuss the remaining two types and the problems and whatever comes our way, we have to discuss that thing. Okay, fine. We'll do it. So today the basics will end today. Today officially we will end the basics and concepts and everything, and we'll start the actual problem solution next class onwards, hopefully. Okay, today itself we will start the problems. Don't worry about that. Problems will start today itself because there is nothing much left. So I was discussing types of function. In the types of function, I was discussing two types. One type is one function. The other one is many one function, which I have already discussed. Let's see the third type, which is onto function. It is very important. Onto function. So what is onto function? So write the definition of onto function in simple language. Function A, function f, A to B. Function f such that A to B, which is defined from A to B, is onto if every element of B is image of some element of A. What does it mean? It means, in simple language, it means codomain should be equal to range. This is an important point, that codomain should be equal to range. If codomain is equal to range, then you will say that function is onto function. Otherwise, something else will happen. And what else will happen, that will I will let you know. Examples also I will give you. A to B. There are two sets A, B, non-empty sets. In A, I have three elements A, B, C. In B, I have 1, 2, 3. Okay. Obviously, A and B will be related. A and B will have some relation. But through some relation, A and B will be related. So the every element of A must be related to with some elements of B. Okay, then only every element of B will have some image in element of A. I mean, every element of B is image of some element of A. Then only it will happen. Every element, I was reading this line, every element of B is the image of some element of A. So f of A is 1, f of B is 2, f of C is 3. So every element of A must be related with some element of B. Are you getting my point? You can say in every element of B is the image of some element of A. So nothing should be left out. If something is left out, then that is not onto function. For example, if I write 4, if I write 4 in this 1, 2, 3, and 4 as well, and that 4 is left out, and then it does not belongs to the onto function. It is not an onto function. So we have to be very, very careful, because now here I'm making just circles. I am making a circle only. And in the circle, everybody can see, even a 9th class student can see that 1, 2, 3, 4, 4 is left alone. So by definition, it is not onto function. It is very easy when there are circles and this kind of representation. But in problems, you won't have circles and this kind of representation. There you will have to check out every value. You have to find out the value out of a function, and then you have to check which one is function is onto and into. So the conditions will be little different. Okay. How to check in case of the problems and functions, I will let you know. Don't worry about that. That procedure also I will let you know. So this is onto function. Simple basic definition, onto function. Codomain should be equal to range. It means, what is codomain? Codomain is B. B is codomain. And what is range? Range are those elements which are related to A. So A 1, 2, 3 are related to A. So codomain and range both are same, because let me erase 4. I forgot to erase 4 now. So let me erase 4. 4 does not belong here. Codomain and range both are same. Range is also 1, 2, 3. Codomain is also 1, 2, 3. So let's write codomain 1, 2, 3. Range is also 1, 2, 3. It's range. Simple thing. Somebody's asking me, do you personally like this chapter? Yeah. The reason is this. I mean, this chapter takes a lot of time for students, honestly speaking. This chapter takes a lot of time for students, and they always seems to have some confusion. So this is the chapter where you have to work hard. Yeah. Once you work that much hard, and once you understand the concepts of this chapter, then you will also start loving this chapter after you pass a certain threshold. No, that what should I say? No, you attain that velocity so that you will cross the universe. I mean, what is that velocity which we attain? Then we will cross the upper atmosphere. I forgot about that physics. Anyway, just leave it. Escape speed, yeah, something like that. Escape speed. So once you will cross the escape velocity, a very good pottery, right word, escape velocity. I was forgot that. So once you will achieve the escape velocity in this chapter, then you will start loving it. Pottery is there any real life application? The real life application is too complicated to put forward in a simple words, but definitely I will do it. Don't worry. I will try to come up with some real life application. Here you go. Next thing which we have is onto function. No, onto is done. Into function. Next one is into function. Onto is done. So here we go. Second time, third and fourth. Fourth type, into function. So what is into function? So into function is quite easy. Into function, whatever definition was written for the onto function, the exactly opposite of it. In into function, in into function, what will happen? Codomain will not be equal to range. In onto function, codomain and range will be equal. In into function, codomain and range will not be equal. That's simple thing, as simple as that. Range both will not be equal. If range will not be equal to codomain, what it means? What it clearly says, some element of B will be left alone. Some element of B will not be having any pair with the elements of A, and that will be left alone. So let me write something like this: A, B, C, and you have 1, 2, 3. And this time what happens? A is related to 1, B is related to 2, and C is also related to 2. C is also related to 2. So 3 is left out. If 3 is left out, then obviously codomain is not equal to range, and codomain is not equal to range, then it is into function. So some element will be left out. Some element will not be having any image. I mean, are you getting my point? Some element will not be image of any of the element of A. Okay. If you find out FA, if you find out FB, if you find out FC, C is none of it. C is none of it. 3 is none of it. Neither 3 is FA, not F of B is 3, nor F of C is 3. So 3 is not an image of any of the elements. So that is not a. In onto function, let me read your doubts. Oh, I did not even tell you my name. Okay, I will tell you my name as well. And somebody is asking me. Sorry, I didn't see your question. So just give me a second. Aarti dear, you asked me a question earlier as well. So let me read both of it. If one has 2 images, then also it is onto. One has 2 images. So let me understand your question. One has 2 images. Onto you're talking. Yeah, of course. I mean, listen, the way you have to remember is B should not, no element in the B should be left out. How many images does it have? It doesn't matter. What matters is nothing should be left alone in B. Everything should have some, everything should be the image of something. Okay, let's move forward. Next thing. Okay, if some of you are having doubts, so just to clear those doubts, I will give you some examples and you will tell me quickly that what category that belongs to. Okay, so let me make some A, B, C, 1, 2, 3. Let me make some cases where I can show you, where I can give it examples. Let me copy it and let me paste it again and again so that we'll have few diagrams. Just give me a second. Here you copy it and then you paste. Then you paste and keep on pasting. Paste one time. Paste one more time. Paste one more time. Paste one more time. This is a good thing. Yeah, so we have this many diagrams. I just copy pasted. Now I will show you some cases. You will tell me what case is this. I mean, you will tell me what is that? Is it onto function or into function or what? So first diagram. I mean, I taught you 4 types. So out of all 4 types, you can tell me what it is that. Okay, is it many to one, onto, into, one to many, whatever it is, one. Okay, not one to many. So first question. A is related to 1. A is also related to, brush is quite thicker. A is related to 1, B is related to 1, and C is also related to 1. What type of function is this? You tell me. A, in the next case, this got a little disturbed. This is unnecessary. Let me finish all of it and then we can discuss. Otherwise, yeah, just give me a second. Let me finish all of it. Otherwise, I will be confused at what you are replying with. A is related to 1, B is also related to 1, and C is let's say related to 2. Next case, A is related to 1, B is related to 3, C let's related to 1. So something is left out. Here A is related to 1, A 2, A is related to 3. Yeah, that's all. It will clear all of your doubts. Whatever theoretical doubts you have, that will clear all of it. Just tell me. First one. Let's talk about the first one. First one is what? First one is many to one. First one is many to one because many of the elements are getting connected with one only. So many to one. First thing I will write many to one. Is there an it? Is there any other type which we can write here? Into or onto? Let's discuss. Into or onto? Into onto? It is into because two elements are left alone. Two elements are left alone. So it is into. First one done. What is biting me? Is it mosquito? Yeah, into. And next one. Next one is this. Second one, let's discuss. Second one is A is connected to 1, B is also connected to 1, and C is connected. Something is left out. So it is in, of course it is into because something is left alone. Into. In B we have 3 alone, so it is into. And what is it many to 1? Yes, of course it is many to 1 because many elements are connected to 1. So many to 1. Third one. Let's discuss the third one. Third one says, yeah, most of I mean all of you are right. Onto into many to 1. Third one. What it is? A is connected to 1, B is connected, C, the 2 is left out. Okay. So basically it is into because 2 is left out. So it is also into function and it is many to 1. Because many A and C both are connected with 1. So many elements are connected to 1. So many to 1. Fourth one. Tell me, fourth one. Very good. Yeah. That's what I wanted to hear and see. All of you are right. Wonderful students. All of you are wonderful. That not a function. It is not a function. Next one. Fifth one. What do you think about fifth one? A is connected, B is connected, C is also connected, and all of them are occupied. So of course it is onto function. It is onto because all the elements codomain is equal to range. All the elements are occupied. None of the element is of B is free. So onto, and it is 1 to 1. 1. It is 1 function because every element of A is related to some other element of B. Just give me a second. My pen got stuck. Something happened and my pen got stuck. Is it got hanged or something? Okay. If you can hear me, this pen got stuck. So just give me a second. Let me figure out why it is happening. Maybe I have to refresh it. Okay. So last one, we were discussing last one. What is wrong with it? I can connect the brush and everything, but I cannot write it. Okay, something just happened, which shouldn't have happened. Every other control is working except the pen. Pen is not writing on the screen, but pen is writing on everything else. Is it? Okay, so do one thing. We'll do it. Salva Kirtana, your pen is working, but on my screen. My pen is not working. Just give me a second. Okay, unfortunately, I have to remove. I hope you have taken notes. I am removing this screen and I will launch this Pent again. I think it is not responding. This Pent application. So I have to close it. I have to reopen it. I hope you have taken notes. Yeah. See, so let's discuss the last one now. Last one is what I cannot write it, but last one is not even a function. Okay, if you have taken notes, that's good. Let's erase it and let's move forward. Yeah, 6 1 is not even function. Okay. 6 1 is not even a function. Maybe the charge got over. My laptop is fully charged, but like it happens because my laptop is working since 8 o'clock in the morning, non-stop. So sometimes it get stuck. It's working 8 o'clock since 8 o'clock in the morning. And if you touch the surface, it is you can like fry the egg on this laptop right now. Okay, you can make an omelette. It is that hot. The lower surface. Okay, so let's relaunch the program again. Now, yeah, exactly. Now I'm able to write it. Now I'm able to run my pen over it. That's good. Here we go. No problem. Abhirami dear, the definitions are different, but in some sense, both are related to each other. Okay, because yeah, both are related to each other. Somebody is asking me a question. Sanjana dear, one which function is also called surjective? So my dear student, surjective and injective is also one of the names which we call for the we'll use for one function and many one function. Surjective, injective. So injective we use one function. One function is injective and the many one function is surjective. One injective. Remember it. So other one will become surjective automatically. Okay, now let's start a problem. Just give me a second. I'm looking for a problem for you. I mean, we are maths students. We will look for the problem. Other people will run away from the problem, but we will look for the problems. So let me look for a problem for you. So I got the problem for you. Here we have, I think I have a photograph of it. Yeah, so the problem is in front of you. The problem is a good problem. Here you go. Control A. Yeah, please note this problem. Let A is a function, A is a set given to us, and show that R is this, R is a relationship is also defined that AB ordered pair AB is such that A, B belongs to A and modulus of A minus B is divisible by 4 is an equivalence relationship. Please highlight this word, equivalence relation. If it is an equivalence relationship, means it should satisfy the three conditions of equivalence relation. Which relation is known as equivalence relation? The relation which satisfies three conditions, which are three. Yeah. So find the set of all the elements related to one. Also find the equivalence class 2. So I will there are so many things which you will learn out of this question, like what is equivalence class. You will learn in this question, you will learn what is equivalence class 2, what is equivalence class, what are the set of all the elements related to one. So this question is quite useful. So I hope you have taken notes of it. Today I'm having some trouble with this pent or tablet, or I don't know what it is. Anyway, so the function a x belongs to z, x is greater or equal to 0, less or equal to 12. This is my set a. So set a will be basically all the elements which belong, which I mean 0 to greater or equal to 0 and less or equal to 12, and x belongs to z means x belongs to integer. So what will be the set a? What will be the elements of set a? Don't you think it will be 1 2 3 4 5? 1 2 3 4 5 6 7 8 9 10 11 and 12 as well. Oh yeah, it is greater than and equal to, exactly. So you can include the 0 as well. Okay. Now, if you, I'm not going to write the relation, because if I write the relation, that will be too lengthy, because I have a set which is having like this many elements. So let's not write the relation right now. Let's look into it, what they want us to do. So relation is given as like this. AB, ordered pair AB should be such that A and B belongs to A. So A and B both should be the elements of A, and modulus of A minus B is divisible by 4. So A minus B is divisible by 4. Oh my goodness. Divisible by 4. The definition is, this kind of definitions will be given to you in the exams. So let's find out the relation. First of all, we have to prove is an equivalence. It is an equivalence relation. So we have to show it. Let this is is an equivalence relation. Find the set of all the elements related to one. Also write the equivalence class. It is a CBSE problem. So it is a descriptive kind of problem. It is not a JEE level problem. It is a CBSE 6 marks problem. 6 marks. I think it came in 2016. CBSE 6 marks. Okay, so it has to be descriptive. You have to explain everything. They said it is an equivalence relation. We have to prove it. We have to prove that it is an equivalence. We have to work on that. So first thing, if it is an equivalence relationship, it should satisfy 3 other conditions. What are those conditions? Can anybody tell me? First thing, it should be reflexive. Reflexive. So it should be reflexive. So for A belongs to capital A, because all the elements belongs to A only. Very good. Resin has replied right. Reflexive, symmetric, transitive. Reflexive, symmetric, transitive. I have to do all of it. Okay. So let's talk about reflexive. So first of all, you have to verify, is it reflexive or not? Can anybody give me the idea how to verify is it reflexive or not? So reflexive are those elements, those in reflexive we will have elements which are doublets. A belongs to R. So you should have pair AA in your relationship R. For example, if I find the relationship for this A, if you will multiply A cross A, you will get 0, 0. You can also get 1, 1. You can get 1, 1, 2, 2, 3, 3. Definitely you will get it. 0, 0 you will have. 1, 1 you will have. You will have 2, 2. You will have 3, 3. You will have 4, 4, 5, 5, 6, 6, 7, 7. Up to what? Up to 12. I'm not going to write all of them. You don't even have to do that. Okay. Definitely there will be such ordered pair which will be doublets. Okay, 2, 2, 3, 3. If you multiply A cross A, you will make all the ordered pairs on in all those ordered pairs. There will be ordered pair which will be 1, 1, 2, 2, 3, 3. So I can write. I can, without even writing all of it, I can write A. Since AA belongs to R, we have confirmed that AA belongs to R. Definitely we'll get it. But and now you have to verify, will it be reflexive? So you have one problem, that relationship is defined as A minus B, factorial A, I mean the modulus of A minus B should be divisible by 4. So Pen, can you please tell me, if I make the ordered pair is A 1, 1, 2, 2, 3, 3, 4, 4, will they satisfy this condition that A minus B is divisible by 4? For all of those pairs, for example, pairs 2, 2, 3, 3, 4, 4. Will they be divisible by 4? Okay, let me check it out. Yeah, I mean, just do it. Yes, my dear. See, the simple logic is this. I was just waiting for your response. A minus A. What I will do A minus A, and that to modulus. So obviously A minus A will be always positive, and 0. I will get answer 0. So for all this reflexive, whatever elements I will write, for every element I will get 0, 0, 0, 0, 0. And 0 is of course divisible by 4. So every element of this function will be divisible by 4. That will come under the relation. So that relation is reflexive. This relationship R is reflexive because we will, in this relation, we will have those elements which will be divisible by 4 because we will get 0. So that will be reflexive. Okay, which will be reflexive. 0 is divisible by any number. Of course it does, without any doubt. So it will be reflexive. Yes, it will be reflexive. Verified. Why verified? Just by if you write this line, enough. Verified. Second thing. Okay, in the relation set, if you write, you will find 2, 2, 3, 3, 4, 4. All those relation will be divisible by 4. So they will be the part of relation. So your relation automatically becomes reflexive. Okay, so Rahul, what I told you, I hope you understood what I said. Next thing, symmetry. Symmetry. Symmetry, I think for this chapter, I have to update my question bank one more time. AB belongs to R. AB belongs to R. Actually, what happened is, before this lockdown, I was in Tamil Nadu. Okay, I was in Madurai. So when this lockdown started, I had to leave all the notes and books and everything. Even one of my laptop is there in the Madurai, because when the flight started, there was a limitation on the flight that you cannot carry more than 7 kgs of cargo. So I had to take literally 7 kgs weight with me. That was my laptop and my little belongings. So again, I have to prepare my notes, and anyway, I have almost done my work. Only few chapters are left. Sorry, I did not tell you my name. Some of you students are asking my name. So being a teacher, I must tell you my name first of all. So my name is Virendra Singh Thakur. Virendra Singh Thakur. Thakur is my last name, and Virendra is my name. Might be a little difficult to pronounce, but yeah. 2615370448. Wonderful, pottery. You have done a good job. So symmetry. Let's find out symmetry. If you want to find out symmetry, what is the condition for symmetry? Let AB belongs to a relation R. If AB belongs to R, A minus B is divisible by 4. Okay. If there is any ordered pair AB, if there is any ordered pair AB in which belongs to R, A minus B will be divisible by R, isn't it? If there is any ordered pair AB in relation R which is divisible by 4, then B minus A is also divisible by A, is also divisible by 4. I'm not even finding all the pairs. I'm just writing it. My logic is so strong that A minus B is divisible by 4. B minus A is also divisible by 4. Why the reason? The reason is there is a modulus. So if A minus B, for example, you are getting a pair. For example, you are getting a pair 5, 1. So 5 minus 1 will give you 4. 4 is divisible by 4. So 1 minus 5 will be also divisible by 4, because the modulus is there. So you will get minus 4, but minus plus. So 4 by 4. So if there is a 5, 1 is there in the relation, 1, 5 will be also there, because 1, 5 is also one of the pair which will satisfy the condition divisibility by 4. So if 5, 1 is there, 1, 5 has to be there. Why? Because there is a modulus. Because of the modulus, 1 5 has to be there in the relation. And if 1 5 is also there and 5 1 is also there, then that function that becomes symmetrical. Symmetry function. Symmetry condition is satisfied. So my logic, by this logic, we can say BA. If AB belongs to R, let AB belongs to R. So BA will also belongs to R. It is necessary that BA will also belongs to R. Hence, symmetrical. Symmetry is justified. Hence, that function will be symmetrical. Understood? Dear, somebody is saying that, sir, 1, 2 is not divisible by 4. We will not take those pairs which are not divisible by 4. I'm talking about only those pairs which Abhiram dear. Abhiram dear, in my relationship, in my relation, I will have only those pairs which are divisible by 4. I won't take 1, 2. I will take 5, 1. Are you getting my point? I will take 6, 2. I will take 2, 6. What else I can take? I can take maybe 8. 8, 2 can I take? No, I will get 6. No. Something like that. I mean, there are so many pairs. So symmetry is also justified here. Symmetry is also justified by logic. By logic, symmetry is justified. If you want to do some more hard work, you can write all those pairs as well. You can make the relation. You can write all the pairs which are divisible by a minus b is divisible by 4. Can you write those pairs right after this problem? Let me finish this last thing. Then I will give you some time to write all such pairs which are satisfying all these 3 conditions. Transitivity. So let's check transitivity. Transitivity should be also justified. AB belongs to R. If AB belongs to R, can anybody justify this transitivity without using any number? Let's do that. That is the beauty of CBSE, and that is the beauty of concepts that sing. If AB belongs to R, then it must be true that A minus B modulus of A minus B will be multiple of 4. 4 times M. What is M? M is an integer. M is an integer. So why you are using M as integer? Because A minus B is divisible by 4 means it must be multiple of 4. 4 times M. It can be 4, it can be 8, it can be 16, any multiple of 4. So A minus B will be 4M. Here M is integer. If I remove the modulus, I will get A minus B as plus minus 4M. Plus minus 4M. Oh, really? We should take ABC. Rahul will take it. We'll take it. Don't worry. AB and then BC will. Yeah, I told you. I have written here. I did not see. I have written CBSE 2016 previous year problem. This problem came into 2016. I have written at the top. CBSE 6 marks. So A minus B will be plus minus 4M. Equation number first. So AB belongs to R. AB belongs to R because AB will give you this. Now let's assume some BC belongs to R. Some BC is there. BC will be what? BC will be also one of the ordered pair in our relation. Okay. So BC is belongs to R. So BC should also satisfy this condition that BC should be divisible by 4. If it is divisible by 4, it will be multiple of 4. So I have written 4 times n. N is an integer. It can be any integer. Plus minus 4n. Equation number second. Let's solve the equation number first and second. If we solve equation number first and second by first and second, this I don't know why, but some students, not all of them, hate this chapter. So you don't have to do it. After few questions, you won't do it. Don't worry. Initially, some of you may do it, but not after a while. Once we'll start discussing some problems, you won't do it anymore. So okay, I have written this. So by 1 and 2, let's do addition. So first question is A minus B. Equation is A minus B plus minus 4M. The next equation is B minus C plus minus 4N. So basically I will edit in addition, B cancel, A minus C plus minus 4 common, M plus N. I'm getting A minus C as plus minus 4 times m plus n. M is also integer, n is also integer. It means, don't you think this part will be divisible by 4 always? For any value of m and n, this part will be always divisible by 4. Can I say so? If I can say so, then I can write a minus c. A minus c. I can say a minus c, modulus of a minus c is 4 times m plus n. I'm doing reverse thing, and this is also multiple of 4. A minus c is also multiple of 4. So a minus c will be also part of my relationship. By that logic, a minus c, I mean a and c, not a minus c, a and c will be also part of my relation. So I have proved that if AB is part of my relation, if BC is also my part of relation, then it must happen that AC will be also part of my relation. So if AB is there, BC is there, and AC also there, then hence transitivity will justify. Write this line, the transitivity. Write this line. Next. Okay, let's speed up the things. Let's finish it off. I hope you're done. Can I move forward? I hope you have done up to this much, and now we have to find out a few more things. What we have to find out, please, let's go back to the question. Question says, find the set of all the elements which are related to 1. So set of all elements, have you taken notes up to now? All elements related to 1. I have to find out all the elements which are related to 1. Basically, they are asking me that one of the elements should be 1 and other element can be anything that is related to 1. So A1 belongs to R. Okay, they are asking all the elements related to 1. Means they are asking what are the elements which are having 1, which are the ordered pair in the relation, which are having one element as 1 and the another element we don't know. So we have to find out all those elements. So obviously in a minus 1 must be divisible, the modulus of a minus 1 must be divisible by 4. It should be divisible by, I will write short form div, divisible by 4. It should be divisible by 4. So can anybody, so all the elements which are belongs to 1, I will write it like this. All the ordered pair. What are the possible values of A here, which belongs to 1? Can anybody give me? 1 can be there. A can be 1 because 1 minus 1 is 0. 1 minus 1 is 0 and 0 is divisible by 4. So 1 will be there. 5 can be there because 5 minus 1 will be 4 and 4 will be divisible. So 5. Is there any other value? 7, 8, 9, 9. 9 minus 1 is 8 and 8 will be divisible. So 9. Do you think of any other value? Can you think of any other value which can be related to 1? No, 0. 0 minus 1 is 1 and 1 is not divisible, dear. Are you getting my point? 0 will not come because 1 is not divisible by 4. Yeah. Okay. So you might be thinking, sir, what is they are asking one more thing. Also write the equivalence class of 2. What is equivalence class? So it is nothing but whatever we have done is equivalence class only. So equivalence class, write the definition of equivalence class, and just if you have written it earlier, no need to write it again. But if you have not written in the question, what is equivalence class? Equivalence class is nothing. All those elements which are related to the given element. Simple thing. So this is equivalence class. This is equivalence class of 1. Please write it. All those elements which are related to all those elements which are related to given elements. So basically they are asking here the given element is 1. Here the given element is 1. So whatever elements are related to the 1, if you write them together and you make them as a set, and that set will be known as equivalence class. So please write it here. This is the equivalence class. What is equivalence class? So this 1 itself is the equivalence class. This square bracket 1, this itself is the equivalence class, because this set is having all those elements which are related to the given element, and the given element is 1. So all those elements which are related to given element is known as equivalence class. When you write them together, that is known as equivalence class. So they are asking you the equivalence class of 2 as well. Basically what they are asking, please reply. I cannot do it, you will do it for me. Do find out this thing. I found you equivalence class of 1. I found you equivalence class of 1. Please find for me equivalence class of 2. What will be elements in this? Write them together for me. Very good, Pottery. You are going in right direction and your answer is right. And yeah, Salva, one more element you are missing. Yeah, now you did. Very good. Aarti is right. Perfect, Aarti. But only 3 students. I'm waiting for all of you. Salva Kirtana, yeah, right. Aarti is right. Pottery is right. Rahul, give it one more shot. You are missing one value. Abhiram is right. Where is James? Do we have James in this session? Today we have 17 students. What is going on here? I mean, is there anybody who's new today, who haven't attended my class earlier? I don't think so. Maybe because most of the names are familiar to me. Pranav, Rahul, Rezin. I think most of you came late today. Sadhna is also here. Sanjana is also here. All of you. Geeta Priyan is also here. Geeta Priyan and Abhirami. And I'm like, is there anybody new? Yes, Rahul. Yeah, got it. Okay. So the equivalence class of 2 is nothing but 2, 6, 10. 2, 6, 10. Why? Because 2 minus 2, 0 divisible by 4. 6 minus 2, 4 divisible by 4. 10 minus 2, 8 divisible by 4. So all of this will be divisible by 4. So for you have to find out all those elements A, 2, which belongs to R. So A can be 2, 6, 10. So that is known as equivalence class. This kind of things they will ask you again and again. Be aware with this. That what is equivalence class? Equivalence class is all those elements which are related to the given elements. And they will ask you like this. Find this. Find this. It means they are asking equivalence class of 2. Find this means equivalence class of 3. Equivalence class of 4 and so on. Next problem. Write the next problem. Next problem is this. Second problem of the day is this. Let function f such that a to b, function f is defined a to b, a function be a function defined as, this time they have given functions as well, defined as, I mean, don't worry, whatever we have done in this problem, we just, I mean, the previous problem, we just understood some basics. Okay, don't worry. We'll raise our level one by one. Okay, so it's just the beginning. Function fx is given as 2x plus 3 and x minus 3, where a is given as, set a is given as r minus 3. And the b is also given as, the set b is given as, b is defined as r minus 2. Can anybody tell me what is r here? Can anybody tell me what is r here? Is the function f, is the function f 1, 1, 1, is the function f 1, 1? Is the function f 1, 1? They are asking simple thing. You have to verify. Real numbers. Very good. All of you are right. It is real number. R is real number because there is no such thing as relation. They have not given any relation. They have, yeah, this question is purely based on function. It is not having any relation part. So simple thing. I have given you a function. I'm raising the things little by bit by bit up. Next class onwards, we are going to solve problems and problems and problems. Okay. So see, this is a function. You have to check for me. The A is this, set A is this, set B is this. The function f, this which is given is defined as A to B, and you have to check for me, is it one to one function or not? Properly, you have to explain the steps and everything. How to check one function, you have to do that. So let me do that for you. Whenever you want to check one function, one function. If you want to check one function, what does the one mean? One mean every element of A will be related to some element of B. Okay, 1, 2, 3. Sorry, ABC. So ABC will be related to 1, 1, 2, 3. Like this. I mean, one-to-one relation. One relation. Every element of one A will be related to one element of B. It means let x1, comma x2. These are the two elements belongs to A. If these are two elements which are belonging to A, set A. Okay, then they should have some image in set. I mean, they should be f of x1. How to check it? One function. So just write, if you have any two elements of A, f of x1 should be equal to f of x2. F of x1 should be equal to f of x2. Images should be equal. One function. So check it out. If for f of x1 is getting equal to f of x2 or not. If it is equal, then it is a one function. Otherwise, it is not. Simple thing. Check it. How we will check? Sorry, I forgot to tell you how we will check. Fx is this 2x plus 3, x minus 3. So f of x1 will be 2x1 plus 3 divided by x1 minus 3, and f of x2 will be 2x2 plus 3 and divided by x2 minus 3. Yes, I mean, now you can please check it out. Are you getting x1 are you getting x1 is equal to x2 or not? If their images are equal, those elements should be also equal. This is what we have to check in one function. So please check it out. If you are solving fx1 is equal to fx2, are you getting x1 is equal to x2 at the end or not? So solve it, do the cross multiplication that I'm not doing, you will do. Cross multiplication, do it, solve it, get the answer. Are you getting x1 is equal to x2? If you're getting x1 is equal to x2 means what? Elements are also equal, their images are also equal. That is the way of checking one function. If the elements are equal, their images should be also equal. If their images are equal, then elements should be equal. That is the condition of one function. Some of you did it. Okay, let me. Some of you are getting confused. 2x1 plus 3. X2 minus 3. Cross multiplication. 2x2 plus 3. X minus 3. So 2x1 x2 plus 2x1 x2 minus 3 into 2, 6. 3 into 2, 6 x1 plus 3x2 minus 3 into 3, 9. On the other hand, you will have 2 into x1 x2 minus 6 x2 plus 3x1 minus 3 into 3, 9. So many things will get cancelled. Okay, so let me verify that thing. 2x1 to x2 cancel. Cancel. 3x2 9 cancel. Cancel. 6x2 6x1 it is equal. Of course it is equal. Of course both parts are equal. You are getting the equal relation. The only difference we have is x1 x2. So from here you will get x1 will be equal to x2. So if x1 is equal to x2 means if you are taking the images equal, yeah, oh sorry. You are taking the images equal and you are getting the elements as equal. So definitely it means this is a 1 1 function. Okay, this is a 1 1 function. X1 is equal to x2. So this is one of the, this is way to identify 1 1 function. This is the most easiest way if you know the function. If they have given you the function, then you can do it. Otherwise, some other methods I will teach you definitely. Salvakirtana, is there any some other methods to verify? Salvakirtana, there are some other methods to verify. Surely there are some other methods which we will discuss in the upcoming problems. Not, there is not this such method which I can discuss verbally here. In problems only I can discuss those methods. So we'll discuss those things. Don't worry. Understood? Okay, that's great. So, please take notes of it. And if you have any other doubts, please ask me. Okay. And when do we have next class? When do we have next class? Just tell me so that I have to prepare few questions for you this time, because we just next class will discuss problems only, will not discuss any concept. So when do we have next class? Okay, so once you will get the schedule, that picture you will get, image, send it to me. Okay, anybody? As soon as you send me. Okay, anyway, so I think that's all for today. We'll have some other problem discussion in the next class, and I hope we are done with the basic concepts. We can go for the JEE level problems in upcoming session. Okay, we'll definitely discuss some JEE level problems. We will discuss in the next session. Remind me at the beginning of the next session if I forget. Anyway, I will not forget. Yeah, next week only. Yeah, that's what. I thought we might have a class on Sunday or Saturday. It's okay. So see you in the next class. Okay, don't worry. We'll see you in the next class. Bye-bye for now. And keep smiling. Be happy. And if you get any trouble with the mathematics, you know where to reach and whom to reach. Okay. If mathematics is giving you any trouble, I hope you know whom to reach and where to reach. Yeah. So welcome all and take care of yourself, everybody. Have a happy weekend. Oh, I really appreciate it, Shri. Thank you very much. Oh, welcome, Janni. Bye-bye, Shamita. See you in the next class.